Okay, so we're going to break this into two parts. The first part we're going to take a look at is functions. Okay, and so a function is a relation in which each input has exactly one output. Okay? The key here is exactly one output. A lot of times for functions, a great example is a vending machine, soda machine. You put your money in, press a button, you get something back. And the trick here is you need to be able to predict what you're going to get back. So, for example, if I have a soda machine and I come up to the soda machine and I put in my money and I press on the Coca-Cola button and I get back a can of Coca-Cola, I'm happy. I got what I wanted. Perfect. Now if I come in and I press the Coca-Cola button and I get a Pepsi instead, well, that's not what I wanted, but if every time I come back and every time I press Coca-Cola I get that can of Pepsi, it's predictable. It has one output. I know what I'm going to get. I'd still call it a function. Now where it'll change is if I press that Coca-Cola button on the first day and get a can of Coke, and the next day I press Coca-Cola and I get a can of Pepsi, the next day I press Coca-Cola and now I get a Mountain Dew, it's changing. It's not predictable. It would no longer be a function. There's lots of ways that we can look at functions: tables, graphs, a list of ordered pairs, a function, like an equation. I'm going to use mappings first because I think they're a good spot to start. And so the trick is I'm going to have an input and an output. I'm going to show you what that mapping is. And we're going to keep these nice and simple. In the first one, I've got three possible numbers, 1, 2, and 3. And my output list is also going to be nice and small, 4, 5, and 6. Okay? So what we're going to do here, I'm going to come down and I'm going to draw for you my mapping. I'm going to say that 1 maps to 4, 2 maps to 5, 3 maps to 6. If we look at this example, no matter what number you give me in the inputs or the domain, I know what I'm going to get for the output. 1 only has one choice. 2 only has one choice. 3 only has one choice. So we would say that this is a function. Okay? Now as our second example, let's come over here. I'm still going to do the same starting mapping. I've got an input, I've got an output. We're still going to go 1, 2, and 3. We're still going to go 4, 5, and 6. I got a little small there. And guess what? I'm still going to say 1 goes over here to 4. That doesn't change. I'm still going to say 2 goes over here to 5. That doesn't change. I'm still going to say 3 goes over here to 6. It's practically the same. Except, I'm going to add one more error. I'm going to say 3 also goes up here to 5. And that's going to be our issue. 1's fine, it only goes to 4. 2's fine, it only goes to 5. But now I come to 3. And you gotta flip a coin. 3 will sometimes give me a 5 back. 3 will sometimes give me a 6 back. The moment I no longer have exactly one output, I am no longer a function. So, since 3 maps to 5 and 6, it is not a function. Okay, that's the detail I'm looking for. Now these mappings I think are a great way to see whether it's a function or not. I think it's very clear and obvious. Do you have 2 arrows splitting off of a particular number? But most of the time we're going to be looking at graphs. And so the trick here is if we want to determine whether a function is, or whether a graph is a function or not, we are going to use the vertical line test. Okay? So the vertical line test. A graph is a function if a vertical, if you need help remembering vertical means up and down. If a vertical line passes at most 1 point. Okay, the moment it crosses more than 1 point on your graph, it is no longer a function. So I'm going to put 2 examples down here to take a look at so we can compare the two. Draw my grid in black. Go over here to... Sorry, trying to get the right pen. Come on. Alright, so I am going to draw this guy. And I'm going to draw this guy. Okay? And here's the deal for vertical line tests. Vertical means straight up and down, right? So imagine a vertical line going from left to right. And if I draw this across, it never crosses my graph more than once. It only ever crosses once. So, crosses once, and my graph is a function. Okay? We can compare this to this guy over here. If I draw this line in right here, use red so it's clear. Boom. There's my vertical line. It crosses twice. So we would say not a function. If there's gaps in your graph, if there's holes, you can ignore those. That's not a big deal. The key is you're checking to see when you draw that vertical line from left to right. If it ever crosses more than once, it is no longer a function.